Hello. Welcome. My name is Alexey Semychev. I'm a principal architect with Salesforce Platform. And I'm here today to talk about Change Data Capture. Change Data Capture is a new product, and as with any new product and many other things in this conference, we're making some forward-looking statements. So I'd like to take a pause and just direct your attention to this slide. Please make your purchasing decisions based on generally available functionality. It's OK to get excited about our cool new stuff, though. What I would like to do today, I want to take a look at the landscape of Salesforce integration capabilities, focusing on data integration stuff. And I'd like to show you how Change Data Capture adds to that landscape. I also have a demo. And we're going to take a look under the hood of the demo, just a little bit, not too much. And I'll have some time for questions at the end. So if you could hold your questions, that would probably allow us to move through this smoothly. Integration with Salesforce Platform. So historically, integration was a lot about moving data in and out. You copy a data set in, you can query it, you can report on it. You move the data set out, and you have it in your system, and you can interact with it using traditional means. There are a lot of tools in the market space. There's a very mature ecosystem of partners that give you the tools to do this extract, transform, load, ETL style of interaction with the data. It has one disadvantage, though. The moment you copy the data, it starts going stale. Depending on how fast your data set is moving, it could take time, or it could be very instant. For example, things like customer information, it changes all the time. And ETL is probably not the best solution in that space. Salesforce introduced another way of dealing with the data sets. You can reference a data set that sits in your database, and you can interact with it within Salesforce as if it was a relational S object right within Salesforce. It's called data virtualization, Salesforce Connect, external objects. All those are different names for this technology. It's great because the data is never stale. Whatever you do with the data, you always access the data set in its latest, as of now, current state. The trade-off, there is latency. You need to get out and make that query and bring the data back in. Another trade-off is some complex merge scenarios, joint scenarios, some reporting scenarios are very hard to do because this is just the nature of the data. And quite recently, Salesforce introduced yet another way of dealing with your data, not in terms of rows, not in terms of relations and tables, but in terms of business events that float around your enterprise and connect your systems together. As enterprise systems grow, they tend to get more complex, and to tame that complexity, they tend to go very asynchronous in nature. Salesforce Platform recognizes that. So Platform Events is the tool that allows you to build large-scale, asynchronous enterprise solutions. And it gives you two kinds of decoupling. Both are very important in my mind. One is the physical runtime decoupling. One system that needs to send a message to another system doesn't need to be aware of that system uptime. It doesn't have to wait till that system is online and ready. There is a messaging layer in between that takes care of delivery of that message, even if the other end is temporarily down. And another kind of decoupling is often overlooked. It's logical decoupling. You have a definition of your business events that different applications can interact over. And they can evolve on their own pace. The schema can change. As long as they publish their events and their schemas into a common repository, they don't have to be aware of each other. They don't have to be in lockstep. The transition from relational data to events is not smooth, though. The drawback of the event-driven architecture is that it requires you to think about your application in a completely different way. So instead of transactions over relations, instead of very rigid and synchronous, kind of very sequenced interaction over your data, you have to deal with eventual consistency. You have to deal with propagation times. And you have to just think about your problem in an asynchronous way, which is quite different. Requires a lot of training to developers. So we introduced Change Data Capture that, in my mind, helps to bridge that divide. Change data capture allows you to get a stream of events that each represent a small change in the data, a finite change in the data, and allows you to maintain a replica of your Salesforce data set outside in your enterprise or elsewhere on the cloud. And each change could be viewed as just that. An account insert means an account insert in my replica. But also, it gives you an opportunity to gradually transition into thinking about those events as business events. An account created, a new inserted account record in Salesforce could mean that a new customer just entered your business. And you could have a business process running out of that on the other end, on the subscription side. The value of change data capture, just another slide to kind of explain more on the value. Here I have SAP and Amazon as two recipients. They receive change events. It allows you to keep your critical data synchronized across the enterprise. It doesn't have the disadvantage of ETL. The data is synchronized and up to date in near real time. It's not full real time, of course. There are propagation delays, but you're not subject to a polling interval, and your data is mostly up to date. You can select what types of data you synchronize. You can choose accounts and leads. You can synchronize all the objects if you want to. And you can build a very complete view of the customer using these tools, a view of the customer that spans from Salesforce to other systems and really encompasses your entire enterprise. Change data capture would not exist without the Salesforce Event Bus. So I must take this quick detour and explain you what Salesforce Event Bus is. Event Bus is the backbone of the asynchronous development in Salesforce. It is based on the notion of time-ordered immutable event log. This is a data structure that was popularized by products such as Apache Kafka. It's offset-based PubSub, in other words. It's quite different from traditional PubSub, but what it allows us to do is to offer you a massively multi-tenant PubSub. You can get a topic or multiple topics in HDE org. It scales really, really well. In the platform, in the Event Bus, we offer processing capabilities right within the platform. You can create an Apex trigger to react to an event within the platform. You can build a process. You can do it declaratively. You can also subscribe outside. There is an API way of establishing subscriptions to individual topics or to multiple topics at the same time. One interesting difference of Event Bus, of Salesforce Event Bus, from other similar products is that Salesforce Event Bus is an inherent part of our Salesforce object data model. So there is a strong schema attached to each event. The event is basically as object in every sense. You define events the same way as you define custom objects. You define fields, use all the types of the fields, and then they become available on the topics for publishing and subscription. So Salesforce Schema is that metadata repository that allows you to decouple publishers and subscribers. Change data capture defines change types for you. They exist as event types on the platform, but you don't have to define them. We declare, for an account, for example, we have an account change event that reflects a change of that object. So enough talking. Let's take a look at some demo. Let's take a look at change data capture in action. Before I go into my demo, I need to explain what I have. I have a Salesforce org that's on the top, where I'm focusing on account and a custom object payment. Change data capture is enabled in the org, so every change to these two objects will be captured and placed on the topic. I subscribe to that topic from Heroku. I have a process running on Heroku. It listens to every change and applies them to two tables in my Postgres database. I have tables named account and payment. And this is a pure replication client. The idea is to keep Salesforce object in sync with a table in Heroku. So my Salesforce org is on the left, and I have two windows. My application is really not a user-facing application. It's a replication client and deals with a stream of changes and a database. The two windows are monitoring screens. On the top, I have a list of events that the application receives. At the bottom, I display the state of data at the present time. So as we apply changes to the database, we will see new lines appear at the bottom. So let's start by creating an account. So now we see that as I create an account, there's a change event create that also includes the type of the object, account, and I print the account name here. And this change is applied to the database, so I have an account entry in the account table in Heroku. And let's log some payments. A custom payment object has been created. We have an event received by my client, and that row is inserted in the second table. Oh, let's log one more. So there's another change event. If you look at my change log, these are events I received from the change data capture stream. Each of them is prepended with a number. So let's create another account. You will see another number. The number is the offset that allows you to subscribe to changes in a durable way. So as long as you remember that number, you can always return it back to us upon any failure, and we will replay that log from that point on. My replication client is on Heroku. Heroku never fails. We'll have to simulate a failure by shutting down my dyno. So we stopped at 201. Let's remember that number. The application is down. My business, in the meantime, keeps going. We enter new payments. And business activity doesn't have to stop while the remote application is down. We have an event bus in the middle. As we restart the client, we repair the failure. My client reconnects, and because I had that offset 201 saved to disk, I can read it from disk and resubmit upon resubscription. Salesforce Event Bus can resume your subscription from that exact point on, so I never miss a change. So my create of payment has been processed by the client. Now my database reflects accurately what's in Salesforce. Let's go back to slides, and I'd like to stay a little bit more on what's really going on. So as I mentioned, it's time-ordered event stream. Each new change adds an element to the right-hand side here, to the tip of the stream. Each subscriber reads from the stream at their own pace. Each subscriber maintains a position into the stream. So as long as you know your position, you can be anywhere on the stream. You can stay very close to the tip. You can process your changes very quickly. Or if you cannot keep up with a spike or a sudden burst of activity, it's OK, because you can be a little bit behind as long as you can catch up. The resumption is done by sending a replay ID that you saved back to us. And you can resume after a very long outage, but we have to keep a certain amount of data, right? We cannot keep the data forever. So that window is 3 days. So you have a 3-day window to replay. If you are down for a longer time, you'll start losing data. There is one important detail about storing that replay ID. I said we're saving it to disk, but the order of saving is critically important. If you save your replay ID, your offset, first, and then apply changes to your database, there's a possibility of a crash in the middle. The crash could save your replay ID in the new state. The changes are not yet applied. It means that when you recover from the crash, you restart, you continue from the next event in the stream, and you lose the changes that you didn't get a chance to process. Well, on the plus side, it guarantees that you never process the same change twice. It's usually called at most once. It's not the option I like, but in some cases it's required. If we reverse the order, we have a different problem and a different advantage. This time you're guaranteed to process changes because you process changes first. Your changes are always in your database. But if you crash in the middle, the new replay ID is not stored. When you recover, you restart from that same point on, you see the same change again. It's OK for an update. It's not OK for a create and insert. Insert will create duplicates. Fortunately, my demo has a relational database. And fortunately, many enterprise systems deal with relational databases. So one little trick helps us a lot. If we store replay ID in the same relational database, if we can put it in the same transactional context, it means that I can start the transaction, I can process all my changes, I can update the replay ID to the next replay ID, and I can commit at the end. So no matter what happens to my system, I'm either all in or there's nothing happened, right? Either the transaction gets committed or it gets rolled back by the database. And my replay ID always corresponds to the state of my system. This is exactly once. This is the one I like. And this is the one I recommend. This allows you to stay exactly up to date. Another thing that I'd like to take a look is the replication protocol itself. This is a little bit technical, but it's important to mention that the payload of the change event is derived from the schema of the object it represents. So we include all the fields of account in the account change events, plus a header that tells you how this change fits into the overall scope of the transaction. For example, we have a transaction key here. It gives you the unique identity of that transaction. So if you have multiple changes spanning the transaction, you can group them together. We also indicate the boundary of that transaction by isTransaction and Boolean flag. So if you find a bunch of changes with the same transaction ID, the last of them will have isTransaction end. It tells you the boundary of the transaction where you can apply those changes if you want them appear atomically in your replica. And of course, there are things like entity name, lead. There's a change type, update. They'll help you to tell what's the change. And there are a few other fields that help you to understand better where that change occurred and how to log it best and track it back to Salesforce. Well, to recap, change data capture provides you a durable stream of changes coming out of Salesforce. We give you transaction boundaries and strict total transaction ordering. You can use it for data replication. You can treat them as data change events, or you can use it for business process integration, where you treat them as business events that kick off other processes in your enterprise. And most importantly, there's a pilot program going on, so if you guys are interested, feel free to reach out. There's some. I'll upload the slides. You'll find them later, so you don't have to write down the links, but you need to reach out to Jay Hurst, who is the product manager. There are also some code snippets. I'd like to also call out some other sessions related to Salesforce integration capabilities. There are a few interesting sessions tomorrow. There are a bunch of interesting sessions today. One that is mostly related to this is triggers and batch apex with external objects. Guess what? Triggers for external objects are change events. So if you want to learn more about change events, see that. So I think we can take a pause here, and if there are any questions, we have about a minute to answer them. Is there a microphone for the questions? No, there's not. OK, let me. The question is, why would you use this instead of the streaming API? First problem with streaming API is that it doesn't cover all the objects. This product is going to cover all objects. Also, streaming API has no schema, so basically get a JSON. Here you get a very strict schema that is derived from changes. So basically, if you want true replication, use this. If you want loosely coupled integration with the UI, streaming API is still a tool. I think there was a question here.
You said about the limitation that this event need to be stored within 3 days, yes, and is able to capture this event. And is the limitation of number of transactions that you can store it and get from this event bus?
So the question is about the depth of the replay window, right? So we measure it in days, and the question was whether we limit the number of transactions we can fit. So transactions are a logical concept. We store them as individual events anyway, and we accept that the data may vary. So we have a little bit of a padding there. So in number of days is the only limitation we have at the moment. It may change, but for now, this is the only thing. You can have as many transactions as you want. Yes, please. Share it with what?
So they were given sharing visibility to the record.
I see. The question is about sharing. So if you change sharing rules and change visibility of the record, unfortunately, we don't catch that now. So we do not provide you a change event if it's just a visibility change. We don't consider that a data change itself. So this is not a product for that. One more, and we'll probably have to do it offline because I'm out of time. Sorry.
So this is outbound data. How about inbound, dealing with change events inbound?
The question is about inbound changes. So change data capture provides you an outbound stream. Inbound stream could be modeled with normal platform events. So if you have changes outside, you can feed them into Salesforce and process them in a trigger, and have logic in the trigger that applies them to Salesforce. So I'm out of time. If you have other questions, I'll be sticking around. Thank you.